we've already covered one half of calculus, which is the derivative, which is the rate of change. And now we're going to look into the other side, which is integration. And as a way of introducing integration, I'm going to work through a practical example here, and I'm going to talk about upper and lower sums. And I'll explain what they are as we go. So let's just have a look at an example here. Say you've got an object that's moving so that its velocity, now this is a velocity time graph, and the velocity is given by 4t squared, and we'll make the numbers easy. So we'll say over the first 4 hours, this is the velocity of this object, and we're pose the question, how far does this object travel in the first 4 hours? So it starts from rest, and straight away we can actually say, well, okay, how fast is it's going after 4 hours? So when t equals 4, v is equal to 4 times 4 squared. So 4 squared 16, 64. So this point here would be the point 464. So one way we know the distance, S is, we'll use D for distancing. Distance equals speed multiplied by time. Okay, and speed and velocity, for this case, we'll just say they're interchangeable, even though we know from vectors they're not. So we'll just say the distance travelled is equal to speed multiplied by time. One way to do a very rough approximation is just to say, all right, we'll just multiply its final speed by the time. So the distance would be equal to speed, its final speed, multiplied by 4, and we'll get that to be 256 kilometres. Now obviously that's nowhere near the right answer. It was only travelling for 64 kilometres an hour right for one instant right at the end. But this is an example of what we use when we're talking about an upper sum. If I was to draw a rectangle that went from here up to there and across, the area of that rectangle is 4 times 64, and that's how we get that. So this, if you like, is using one strip. We're going to just look at one strip from 0 to 4. So one strip, the upper sum is equal to 256 kilometres as an approximation. The lower sum is calculated by assuming that the object never got faster than 0 kilometres per hour, and it went at 0 kilometres per hour for the whole 4 hours. So that'll be 0 times 4. So that'll be 0 kilometres. So somewhere in between there is how far it actually travelled. The lower sum you can't really draw it. It'll be just a straight line across there. And the area of that, because it has that rectangle has no width, so it'll be 0 times 4, which is equal to 0. So okay, let's go and split this up into 2 strips. And the 2 strips would be, let's do them in another colour here, in green. So we're looking at this strip here, across to there. Now, the upper sum would be the area of that green rectangle, and then it would be the area of this green rectangle. So for 2 strips, the upper sum, so I travel for 2 hours at that speed. Now that speed would be 2 squared times 4, so that will be 16. So it'll be 16 times 2 times 16 plus, so we're assuming that it travelled for 2 hours at 16, and then these 2 hours at 64. and we get 32 plus 128, and that's equal to 160 kilometres. So it's come down markedly by just splitting this up into two strips. What would the lower sum be? Well, it's assuming that we did 2 hours at 0 plus, and then it's assuming that we did this 2 hours so it'll be, the lower sum will be 2 hours at that, and then 2 hours at 16. So that'll be 32 kilometres. You can see the gap between these two here is 256, and you can see the gap between these two here is a little bit less than 130. So it's getting closer to the actual distance. And we'll just do one more, and let's split it up into 4. 1, 2, 3, and 4. So the upper sum here would be the area of that, and then this one here would be the area of that, this one here would be the area of that rectangle, and this one here would be the area of that rectangle. So using 4 strips, the upper sum. Now this will be equal to 4. So it'll be 1 hour at 4 plus 1 hour at 16 plus 1 hour at, we haven't worked that one out yet, so this one here will be 3 squared, which is 9 times 4, 36. So that one corresponds up here to 36. So the area of that little strip there will be 1 times 36 plus 1 at 64. 4, 20, 56. 56 plus 64 is 120 kilometres. Once again, it's dropped down a lot. And the lower sum would be equal to 1 hour at 0. Now, this one here, the lower sum would be the area of this bit here. So there's the upper sum for that hour, and there's the lower sum for that hour. Obviously, the distance travelled is somewhere in between though, so it'll be 1 times 4 plus 1 times 16 plus 1 times 36, and for that we get 56. And once again, the difference between those two has come down. So we can see by doing upper and lower sums that we're going to get a rough idea of the area, or the distance, travelled. The more strips we've taken, the closer we're getting. So if we average these two, so we just add those two together and divide by 2, so the area of the upper and lower sum is 120 plus 56 divided by 2. So averaging them like finding the area of trapezium. So that up there and a straight line back to there. And the second hour would be there to there, and then a straight line back to there. There, and a straight line back. So finding this area is like finding the area of all those trapeziums. So when we do that, we get 176 divided by 2, so that'll be equal to 88 kilometres. So by adding the upper sum and the lower sum, so 120 plus 56 divided by 2, 176 on 2, which is 88 kilometres. So that's an approximate area. It's an approximation of how far it has travelled. by averaging the upper sums and the lower sums. Now, we'll find out later on that the actual distance and, if you like, in this instance, integration, which is the opposite of differentiation, would allow us to actually calculate this, will be equal to 85 1/3 kilometres. So by averaging, when you only got one strip, you're going to be a long way out. When you've got two strips, when you average those two, you're going to get 91, which is a fair way out. 4 strips, if you had 20 strips, you'd get even better. Now, integration will allow us to actually work out an infinite number of strips and to get the exact answer, which in this case was 85 1/3. So we'll get stuck into integration in the next section.